Yeah, guys. Today's video is about factoring, which of course is one of the definitely the most important like skills you can have. Algebra 2 and higher classes. So, uh, definitely want to again, like I've been talking to you guys about in class, if this is something you know in the past that you've struggled with, or as you're going through this, you feel like you're struggling, you really need to speak up and um, get extra help so that as we keep doing this throughout the lessons that um, you're able to do this kind of step and not let it drag you down away from the other things you're supposed to be learning. So remember that basically, I really like this idea that if you think about factoring as being reverse distributive property, it can really help you figure out what factoring is all about. We think about what factoring is. It's something like if I distribute 7x to like 2x minus 3, right? And so then I end up with 14x squared minus 21x, right? And so that idea like of factoring is taking this expression and pulling it apart and saying what could I have distributed into this in order to get this. And so as we go backwards, our answers should always end up with parentheses in them because we're undoing the distribution. And so since distribution is getting rid of the parentheses, then factoring should put the parentheses back into the problem. And the other idea is that something oftentimes it's outside of the parentheses, and then we have another expression inside the parentheses. And as we factor what's called factoring completely, we want to make sure that what's inside the parentheses no longer has anything in common, because there are lots of different things I could have multiplied together to get this, but the complete factorization would require us to have nothing left in common inside of the parentheses. So things to think about. So the first way we're going to start off with is with just finding that greatest common factor, which is kind of what I just did there. So, what is the greatest common factor between 14x squared and 21x? And so, 14 and 21 both have 7 in them, and x squared and x both have an x in them, so that 7x would be the greatest common factor of those. And you ask yourself, 7x times what is 14x squared? Well, it's 7x times 2x. 7x times what is negative 21x, and that would be negative 3. So looking at something a little bit more complex, factoring by pulling out the GCF, I want to look at each number as kind of a starting place. So the 2, the 8, and the 6. I'd say what number goes into 2 and 8 and 6, and of course that would be 2. And then look at the kind of each variable in turn. So a to the 4th, a to the 3rd, and a to the 5th. So what's the most that they all have? The most they all have is 3 a's. So a cubed, right? A cubed does not have any more than 3 to share, so or have in common. So generally a good rule of thumb is that the lowest exponent will be the one to go with. And then the next variable here, b's. So what's in kind of that same way, what's the least amount of b's I see? That would be the limiting factor. So b squared would be my GCF. And so then that would be on the outside of the parentheses. And I want to say, well, what's left inside? So 2a cubed b squared times what? It gives me this, right? So what am I missing? Well, 2 times 1 is 2, so I would put a 1 here, but I don't need a 1. A times what is a to the 4th? Well, I would need another a. B squared times what is b to the cubed, right? So I would need another b, so I need ab. To go to the next term, right? 2a cubed b squared times what is negative 8a cubed b to the 5th. So I have 2, I need to get to negative 8, that's going to be a negative 4. I have a cubed, I have a cubed, so that's the same, so I don't need anything else. B squared to b to the 5th would be 3 more b's, so 4b cubed. And then last term here, 2 times what is 6, that'd be positive 3. And then a cubed, I'm missing 2a, so I need to get to a to the 5th, so a squared. And then b squared, well, I have b squared, so that's not changing. So there would be my GCF factoring. So last thing I want to do is kind of make sure is nothing in these, all three of these don't share something. So this one has an A and this one has an A, but this one doesn't, so they don't all share an A. You know, this one has a B, this one has a B, but this doesn't, so they don't all share a B. And none of the numbers, the 1, 4, 3, have anything in common. So I have done the complete GCF factoring, so that's done. This next one is a step along the lines of how you would have learned factoring by grouping. Noticing that, let me back up a little bit. That one thing it's kind of hard to tell sometimes is that this is all one term, right? And then this is all one term since there's multiplication here. That creates this as one term and this is one term. As I look at, hopefully you guys didn't see that, as I look at each term, what do they share? Well, they both have a b squared minus a. And so I can pull that b squared minus a out of both of them, even though it's something complex. I can still take it out of both of them and still ask myself that same question. What b squared minus a times what is this? Well, that'd be b squared minus a times x. And then b squared minus a times what is this? And that'd be b squared minus a times 6, or positive 6, right? So there would be my GCF factoring. And so that is like, when you get to here, you just, since they both have this piece in common, I can pull that out. It just comes out to the front, and we're just left with these kind of leftover pieces, the x and the 6. So that would definitely be a part of factoring by grouping that sometimes we forget that we do it. It's actually pretty easy. AC method is the next one. Part of the reason we went over something earlier, how do we know if something's quadratic? How do we know if something's a trinomial? Like when you're doing a quadratic trinomial, or really any trinomials in general, like you want to try to use the AC method at some point. So do we have 3 terms, right, is really kind of one of the big things. Like, so if there are 3 terms, you should probably be trying the AC method. Again, not that it's always going to work, but it's kind of your go-to guy. And the AC method is all about taking that A value, which is 5, and your C value, which in this case would be negative 6. So 5 times negative 6, which gives us 30. And comparing that to our B value, which in this case is 7. Okay, so remember, it's not 5x squared or 7x, it's just the numbers we're looking here. And we want to find factors of AC, so factors of negative 30, that sum to B. So I want to find factors of negative 30 that sum to 7. Okay, and the way if any of you guys were with me last year, this is how I always wrote it. I wrote AC equals negative 30, and then I would just write a little arrow and say, okay, I want to get 7 out of that, and then I would start listing stuff underneath there. This just has like a little kind of table space here to do that, but same thing. So I want factors of 30. So 1 times 30. There's no way I'm going to add that to 7. 2 times 15. Can't add, or even if one of them is negative, can't add that to 7. 3 times 10. Ooh, I could find a way to get that to be 7, and then we also have 5 times 6. Those are all the factors of 30, and the only one that even has a chance of becoming 7 is 3 and 10. But I do want negative 30, right? Not just 30. So one of my numbers needs to be negative. So if I had a negative 3 and a positive 10, that would give me 7. And so you take those numbers, that negative 3 and that positive 10, and you put those back into the problem. So 5x squared. And so we're saying then plus negative 3x minus, plus 10x, since that was positive, minus 6. So basically, again, been a while for you. You're taking this 7x that we had earlier, and you're finding a special way to break it up. Okay, a unique way to break it up, where those two numbers multiply to be a times c, but also add to be b. So what two numbers multiply to be ac, but also add to be b, and that's a unique. And you put those two numbers here as a way of breaking this number apart. All right, and you're finding a way to turn this into 4 terms, because then you can do your factoring by grouping with that GCF factoring into each group. So ask yourself here, how do I what can I pull out of both of those now? And those both have an x in them. So I would take that x out, and then it'd be 5x minus 3. And then looking here, what do these have in common? Well, 10 and 6 both have a 2 in them. Right, so bringing a 2 out, and then 2 times 5x is 10x, and then 2 times negative 3 is 6, or negative 6. So. And then remember, this process hinges on that these two binomials are the same, right? Just like we had up here. If you ever get to the point where these two are not the same, either you're doing something wrong, or the problem is not factorable using this method. Generally, it's you're doing something wrong, just FYI. And so then that last step, right, since they both have a 5x minus 3 in them, I can take that out. So I'm going to take this out of there. So 5x minus 3. And then I take those leftover pieces, that x and that plus 2, and I write those next. It is very important that you have a plus sign here, or a minus sign, depending on what the sign of the number you take out is. It can't just be a space. There doesn't need to be a plus sign there. And as you write this, now we're saying it's 5x minus 3 times x plus 2. So you generally would just put the parentheses next to each other there. So there's our final answer on that, guys. I'm not sure what. Yeah. So we just took the GCF out there. So again, the idea is that 5x squared plus 7x minus 6 factors into 5x minus 3 times x plus 2. If we FOIL this back together, you would get this again. And that's what factoring is. We just undistributed. So if we did redistribute, we would get back to here. So I'll do a couple of these with you, then I'll have you try one. So a times, so I see a trinomial, right? So first thing I'm going to do is glance to see if there's any GCF here. Always look for a GCF first, and 2 and 9 and 9 don't share anything, so no GCF. So I'm going to go to AC, which is 2 times 9. And then it needs to add to B, which is 9. So I need factors of 18 that add to be 9. And some of you might jump right on that. I know that, otherwise you need to start listing them out. 1 times 18, not going to give me 9. 2 times 9, won't give me 9. 3 times 6, ooh, there's a 9. All right, so I need a positive 18 and a positive 9, so I can just add 3 and 6. So I'm going to rewrite the problem. 2x squared plus, and it doesn't matter what order you write this in. If you want to write 3x first or 6x first, it does not matter. So then plus 3x plus 6x, and then your plus 9. Right? So again, this 9x has been broken apart using these two unique numbers. And then we go into the factoring by grouping, which is you break this in half. Look for that common factor in the first two, so which would be x times 2x plus 3. Look for the common factor in the second two, which would be positive 3. 3 times 2x is 6x, 3 times 3 is 9. Again, there needs to be a plus sign or a minus sign here. You cannot just have nothing. I check to see if I'm going okay, because these two are the same. If they're not, you need to stop and see what's going wrong. Don't just force them. I see a lot of students try to force it. And once they are the same, I grab those two things that are the same like that. 2x plus 3, those go together. And then the leftover pieces on the outsides go together. X plus 3. So there's my factorization of 2x squared plus 9x plus 9. Kind of double check, is everything as small, as factored here as possible? Do 2x and 3 have anything in common? No. Do x plus 3, x and positive 3 have anything in common? No. So this is fully factored. Try another one. Got a trinomial. There's nothing for me to take out of all of them right now, so I always look for a GCF, but I move past it since there's not one. Take my a times my c, which is negative 6. I need negative 6 to add to 1. So what are my factors of negative 6 to add to 1? Well, not a lot of ways to get 6. 1 times 6 and 2 times 3. Of course, negative 6 would come from negative 2 plus 3. So I'd have 6x squared And again, I can take it anywhere I want. So I'm just going to put negative 2x and positive 3x, and then minus 1. Break it in half. Look for common factors, which would be 2x. 2x times 3x is 6x squared, and then 2x times negative 1 is negative 2x. Look for common factors. 3 and 1 don't share any factors besides 1. So remember, your go-to guy is 1 if there's nothing else. That'd be a positive 1. And 1 times 3x is 3x, and 1 times negative 1 is negative 1. And then again, so now that these are the same, all right, now that we see that they are the same, bring those out front. And we have our leftover pieces here. 2x plus 1. So there's our factorization. Nothing in common here. Nothing in common here, so I know that I'm done. All right, I'll have you guys try C, and I'll throw the answers into the Edpuzzle. Hopefully that goes well. Use that AC method. This next part is factoring perfect squares, so it's kind of like a pattern-based factoring. It's really one of those things that if you recognize it, it can speed things up a lot. If we were going to try to do the AC method on here, it could get pretty messy because our first step would be to take A times C, and that's going to give us a really big number. And we're going to figure out what are the factors of that giant number that added to be 84. So really what it's going to come down to is you guys recognizing that, hey, 49 and 36 are perfect squares, so there's a good chance that this has a special type of factoring, okay? So recognition, so when I asked you guys the other day about writing down those perfect squares 1 through 15, and starting to recognize those, this is really where that comes into handy. If you don't recognize that, then you're gonna you can cause yourself some headaches. So a trinomial is a perfect square if both the leading coefficient and constant are perfect squares. Also, the middle term needs to be twice the product of the square root of the leading coefficient and the constant. So it's kind of a weird statement. So twice the product of the square root of the leading coefficient and the constant. So the square root of the leading coefficient, so the square root of 49, is 7. Sorry. And then the square root of the constant, which is 36. So 6. Well, the product of that is 7 times 6 is 42. And so it says the middle term coefficient has to be twice that, which is 84. Okay, so because the square root of this is 7, the square root of this is 36, the product of 7 and 6 are 42, and twice 42 is 84. All right, so it matches the rules. Okay, then this is set up to be a perfect square trinomial, that's called, and we can find a faster way to factor it. Okay, so there's a lot of set of rules in order to, can you do this? There's a lot of kind of boxes you have to check in order to do that. So what we're looking at here is how do I kind of break this apart? And so what it comes down to is those square roots. So recognizing that this is a perfect square, I'd say, well, what is the square root of 49x squared? Right? What times itself is 49x squared? And that would just be 7x. Make sure you include the x there. And then I'm going to go to the end and say, well, what would be the square root of 36? And of course, that would just be 6. And then in the middle, it's supposed to be twice their product. So twice 7x times 36. Or sorry, 6. Okay, so I start on the front, figure out what the square root of this is, go to the end, figure out what the square root of that is, and in the middle, it would fill in both of them. Okay, and so where this ends up going, if you run through all the factoring, this ends up going to be equal to 7x plus 6 times 7x plus 6, which of course would be 7x plus 6 squared. Okay, so if I took 7x plus 6 times itself and then FOIL it all out, I would get here. So I'm going to do another one of those with you. Okay, that's kind of a weird idea. But it's finding a way to shortcut this so that we can go straight from here down to here, recognizing if the numbers follow certain rules, and then we can just jump straight to this answer. We don't have to do all this business in the middle. Okay, that's the idea. We want to find a shortcut. It's very, very, very pattern-based, very visual. You have to recognize it for what it is. Okay. So when I look at the beginning, I say, oh, hey, 64, that's a perfect square. Oh, 25, that's also a perfect square. Let's check out that middle, see if it fits the rules. So that square root here would be 8. Square root on the end would be 5. 8 times 5 is 40. And 40 times 2 is 80. So first term is a perfect square, that constant's a perfect square, and the middle is twice their product. So this fits all the boxes, checks all the boxes as far as, can I just run this as a perfect square trinomial? And I can. And so once I know that, I know the answer is going to look like this. Something squared. And because this first sign is a plus, this will also be a plus. Anytime you do a perfect square trinomial, the second sign will always be positive. Because if you're doing a square, right, squares are always positive. Positive times a positive is positive, and negative times a negative is always positive. So this last term is always positive. It's the first sign, the middle term sign that's going to tell us the sign of our answer. So since that's positive, this is positive. Then I just look at the square root of this, which is 8x. Don't forget the x. And the square root of this, which is 5. And I'm done factoring. Okay, so as long as it checks the boxes, right? Is this a perfect square? Is this a perfect square? Is this twice the product of the square root of each of these? Then you can go right into that. I'll do it one more time with you. So, is 196 a perfect square? If you check that list, it is 14 squared. All right, is 9 a perfect square? Of course. So I have 14 times 9. 9, why did I say 9? 14 times 3, which is 42, times 2, which is 84. So, boom. Right? Perfect square, twice the product of the square roots. So it matches what we needed to match. I know that means it's going to turn out to be something times itself, because the first sign, or the sign of the middle term, is negative. That means I'm going to have a minus sign here. Then I just look at this, say what times itself is 196x squared, which would be 14x. What times itself is 9, which would be 3, and I'm done. We didn't do a lot of this in Algebra 2. We wanted you guys more to focus on that AC method and things like that, rather than like kind of memorizing these pattern ones. We're just trying to push things a little bit further now, so and trying to get you guys to start recognizing things more than just kind of burning through them. I could sit here and do this problem with the AC method. It would just take a lot longer. And so we're just trying to get you guys to push a little bit further, think more abstractly, recognize patterns more. And so then just kind of like, really again, it's kind of a grind your way through it with the AC method. So we did some of that with the difference of squares stuff, and that was definitely a type of factoring that we had you guys look at a lot, because it is so useful. And so you guys should have some semblance of this, like this idea that something that's almost like itself, where that middle sign was different, but so this should be kind of familiar, but we didn't do this specific type of factoring last year in Algebra 2. So difference of squares again is, like I was just talking about, is again a kind of a pattern-based one, a recognition. So difference meaning subtraction, so it has to be subtraction in the middle, and then kind of like this last thing we just talked about, the first term has to be a perfect square, so something like 49x squared, and the last term has to be a perfect square, so maybe something like 25. So if the first term is a perfect square, and the last term is a perfect square, and then it's subtraction of them, That is a difference of squares factoring problem. And again, you kind of say, well, what is the square root of 49x squared, which would be 7x? What is the square root of 25, which would be 5? And once you know that, it's going to be 7x plus 5 and 7x minus 5. So this is definitely one that you guys should be familiar with from last year, that how it looks when we're done, that they're almost exactly the same, except for that sign in the middle is different. So, it's so close to this, right? How when the signs are the same, how the problem looks different, right? That's not a binomial like this is. Right? This is only two terms because that plus sign and the minus sign end up canceling out that middle term. Well, because the signs are the same here, that middle term doesn't get canceled. Okay. Then we did do sums and difference of cubes last year. We don't do it a lot, so it might be one of the things you forgot. So this is going to go back to now our list of cubes I was talking about the other day. Can you recognize a cube when you see one? So if I have a perfect cube, like 64x cubed, and then plus 27, and then it's plus sign between them. All right, so I have a perfect cube plus another perfect cube. This can be factored using cube roots. So the cube root of 64x to the third is 4x. The cube root of 27 is 3. And the way this ends up coming out, so that 4x and that 3 go here in this first binomial, and the sign of the problem was a plus, and so the sign of our binomial is a plus. And then we take that 4x and we square it. So 4x times 4x, which is 16x squared. See, a lot of students forget to put the square on the x. And then we're going to take that 3 and we're going to square it also. That's going to be the 9 back here. And in the middle, we multiply them. So I'm going to take the 4x and the 3 and I'm going to multiply them, and that's going to give me 12x. I'm going to talk to you guys about kind of a way to remember this, okay? Don't freak out. So if I multiply 4x plus 3 times 16x squared minus 12x plus 9, if I multiply all that together, I would get this back. Because of this one minus sign here, it does some canceling stuff throughout the problem. It kills off the square and the x terms, and we end up with just these back when we're done. And this would have been something you guys would have seen in Algebra 2, like we would have walked through it one way and then walked through it backwards so you could see how things actually do cancel out. I'm not going to sit here and do that with you guys again, but if that's something you need to see, you just need to talk to me. So this is the factorization of this is this, right? And you might be questioning, like, am I done because of how big this is here? And there's a property of this type of factoring that these trinomials that you end up with are always prime. So these will never be factorable. So you don't need to worry about trying to do like the AC method or anything like that on there. Okay? So you're actually done here. Notice how these don't have anything in common. This will also be prime, so you can't factor it. Similar problem, what's called a difference of cubes, right? So now it has a subtraction between them. So like something like 125a cubed minus b cubed. Okay. So do I have two perfect cubes? This is a perfect cube, this is a perfect cube, this is a subtraction, so this is a difference of cubes. Again, it's based around cube roots. So what's the cube root of 125? Well, it's 5. And then I'd need an a. What's the cube root of b cubed? Well, that'd just be b. Okay, so just identifying that. And then that 5a goes in the first spot. The b goes in the second spot in the binomial. Okay. And then just like before, we square the 5a. So 5a times 5a is 25a squared. Not 10a, not 10a squared. 5a times 5a is 25a squared. And then the last term is the b squared. So in that case, just b squared, right? And in the middle, I multiply them. So I take 5a times b, which would be 5ab. So again, the idea is if I distributed 5a minus b into this, and all the canceling, combining like terms of business happens, we would end up right here. Okay. So how do you remember how to do that? And so the method I teach is called CC-SOPs. There's other methods. This is just a mnemonic device, kind of like FOIL or something like that. Just helps you remember what to do. So CC-SOPs stands for cube root. So that's what the CC stands for, cube root, and then cube root. So what it's telling you to do is take the cube root of the first term, that's 5a, right? Take the cube root of the second term, that would be b. So just kind of identifying those. And those always go in the first set of parentheses. I guess let me just do a problem. Let's say like 1000 x cubed minus, let's say, I forgot my cubes here. What's 7 cubed? 343. Okay. So I'm going to take the cube root of this, which is 10x. I'm going to take the cube root of this, which is 7. Those are going to go in the first set of parentheses. Because the problem is a minus, I put a minus here. This is always the same sign. Okay. So notice that on the sum, the first sign was a plus. On the difference, the first sign was minus. Okay, so always the sign is the problem. And then S stands for square. What that's telling me is to, in the next set of parentheses, the first thing I do is square this. So 10x times 10x, which would be 100x squared. O stands for opposite. So that means I'm going to use the opposite sign. So that would be plus. P stands for product. So I'm going to take 10x times 7. I'm ignoring the sign because I already did the sign. So 10x times 7 is 70x. The last sign is always a plus. You notice that on the other problems. Okay, the last sign is always a plus. And then the last one is a square again. So those S's both stand for square. And this time I'm squaring the 7, which is 49. So this is just a mnemonic device to help you remember like the steps to do in order to get the factoring of this. So 10x cubed minus 343. If I factor that, I would get 10x minus 7 times 100x squared plus 70x plus 49. And again, this is prime. There's no way to factor this. You don't need to try. Okay, so CC-SOPs, cube root, square, opposite, product, square. So find the cube roots of these. Those go here in the first set of parentheses. And then after that, I kind of ignored this, if you noticed. I never went back to it. I found the square of this. I did the opposite sign. I found the product of these two things. Always a plus. And then I squared this. And that goes there. Right? I never went back to the original problem after I did the cube roots. Little tip. All right, last thing here, factoring just these problems. So what you always want to pay attention to is how many terms there are, right? It's not, none of these are trinomials, so I won't be doing the AC method. Always look for a GCF if you can. There's nothing in common between 81 and 100, so no GCF to take out. I see perfect squares, so I'm going to be looking for a difference of squares factoring. And I love difference of squares factoring. It's super easy. Always remember that they're exactly the same except for one's plus and one's a minus. It doesn't matter which one you're at first. And then I'm looking for the square root of 81y squared, so 9y. And I'm looking for the square root of 100, 10. And I am done. Easy peasy. Love difference of squares. Okay, 2 terms. Not going to do the AC method. Nothing in common. I see a perfect cube here. I see a perfect cube here. 1 is a perfect cube. Right? 1 times 1 times 1. So I'm going to do my CC stops. CC means cube root. So in my first small set of parentheses, I'm going to cube root 1000 to x cubed, which is 10x. I'm going to cube root 1, which is 1. And then I always use the sign they gave me. And then I go to my big set of parentheses. My trinomials next. I stop and think. So I did my CC, and now I need my stops. S stands for square. So I'm going to take 10x, I'm going to multiply it by itself. 10x times 10x, 100x squared. And then I'm going to do the O, opposite sign. So I had a minus, now it's a plus. And then I'm going to do the P, which means product. 10x times 1. Again, don't worry about the sign, you've already done the sign. 10x times 1 is 10x. The last sign is always a plus. And then the last number, the S, another square. Now I'm squaring the 1. 1 times 1 is 1. So there is my factorization for 1000x cubed minus 1. So I'd like you guys to try the last one and see how that goes, and I'll throw that in the ed puzzle. And then there's the homework down there, of course. All right, hope that video wasn't too long. Talk to you guys later.